Hello everyone. In this video, we will learn how to classify an image using Google Earth Engine. Now, as you know from your remote sensing classes, we have two types of classification. We have supervised and unsupervised. So for this video, we will do a supervised classification using the random forest classifier. Okay, so I will discuss the lines of code here. I will no longer be typing them out so that we can save some time. Okay, so let's take a look at the data that we have here. So we have the political boundaries. This is the municipal level for the Philippines, and then we have Sentinel-2. So this is the data set that we've been using since the very first video of this lecture series. And then this vegetation built up and bare right here are the geometry points. So these will be the training and validation points that we're going to use for the supervised classification. Okay, so now for the first lines of code, we have var RGBVis. As you know, this is our visualization object. When we add a layer, this is the visualization parameter. These are the parameters that we're going to use. Then we have our ROI. So as you can see right here, for the political boundaries, we just filtered it. So we created a filter using metadata name to, and this is Pilar. So this is Camotes near Leyte. And then we converted it to a geometry object using this dot geometry function right here. Then we also created a masking function. So if you're not quite familiar with this, there is a video all about masking, and you can view that. So we also filtered our Sentinel-2 data. We have here a metadata filter. So the cloudy pixel percentage is 10%, less than 10%. And then we have another filter for the date. So this is from July of 2020 to September 30, 2021. And then we have another filter for our geometry, for our region of interest, ROI. And then we applied the functional programming concept dot map, the mask to clouds function, so that our cloud mask will be applied to each image in this collection. Okay, so after that, we filtered. I mean, we got the median of all of the filtered images, and then finally we clipped it using our ROI. So we have filtered median, and then we dot clip, and then we input. We entered the ROI object, geometry object, as the parameter here. Okay, so if we take a look at our area here, this is our area, and I've already created the points. Okay, so it's best. Of course, I'm going to teach you how to add points. No, so okay, so let's run it. Let's wait for a bit. Okay, so let's zoom in. Let's zoom in. So as you can see, this is our output. This is the median of the filtered Sentinel images. So we are at this line here. And then if you want to create points, so you just use this interface right here. So you can create geometry points. So let's say I want to create a new point. Okay, a new what do you call this? Um, a new land cover type that you want to classify. Let's say, for example, what do you want to classify? Say, for example, mangroves. Okay, let's just put that here, and then you can you can click on this gear right here for the settings, and then you can write here mangroves, and then you put the input it as a feature collection, and then property. So the property that we're going to input here is land cover. So you will see where this property will be used later, and then you will input a value. So we will have, since we already used 0, 1, and 2, so I will show you that later. So let's just put 3 here. Okay, so and then you select a color. So let's just stick to red, since this is just an example. Okay, so you then go to the mangroves here, and then mangrove areas here, and then you can just click some points there. And then if you go here, you can see these 4 points are already created. See? And then that's basically how you create the points. So in the add more points. Okay, so let's take a look at the other points that we have. So let's see right here. We have the vegetation. Okay, so we will be classifying the image here, the median image, for using the vegetation, the built up, and the uh, bare land training points that I have selected. Okay, so the land cover here and the value is 0, and then for the built up, still the property name is still the same, and then 1 for the value, and then for the bare land, we have land cover still, and then value is 2. Okay, so we will be using that for creating the sample training set and validation points, as we will get to know the syntax later. Okay, so that's basically it for creating points. Now let us try to delete these points right here, because we will not be using these mangroves here. So are you sure you want to delete the mangroves? Yes. Okay, so as you can see right here, we have 70 vegetation points and 70 built up points and 70 bare land points. So you are already familiar with this in remote sensing. Now you just select the points here. If you haven't been to the actual place, then you can just use the satellite image as a reference here. But um, it's really important to actually go to the field. So as you can see right here, I've created points on the built up. As you can see right here, there are buildings here. I've created points there. And for the vegetation, there are lots of options for the vegetation. And you can see right here, these are the bare land points that I've selected. So once you've selected these points, created these points, it will reflect here the vegetation, the built up and bare. It will automatically reflect here. And then once you've created those, you will convert them into feature collection. Okay, so we have this vegetation. So we created a var inner variable to hold the feature collection. So we have vegetation GCPs, and then we converted the vegetation to feature collection object. And the same thing for the urban GCPs and bare GCPs. So that's what we did. Okay, so the next thing that we're going to do is we're going to merge all of these feature collections. So we have here, we created a variable called merge GCPs. So you basically use this merge function, so vegetation.merge, and then the result of that will be merged again to the bare points right here. And then, as you know, from our sample points, we will select from all of these points a subset for training and subset for validation later on after the classification. So in order to do that, we need to use this random column right here. So merge GCPs, and then if you use this random column function, it will create another property. It will create another property of the points, and then it will assign a value from 0 to 0.999 randomly to all of the points. And then using that property, we can then filter, as you can see right here in the next step. For the training GCPs, so we use GCP.filter. Then we create a filter, and using the random property, value lesser than 0.6 will be for the training GCPs, and then the validation GCPs will be greater than or equal to 0.6. So basically, we have 60% of our points will be training, and then 40% will be for validation. Okay, so let's print the GCP here, so that we will see what this random column really does. Okay, so we have right here. Take a look at the console in the upper right. So as you can see right here, we have columns, and then we have land cover, which is an integer, and the random is any. So I don't know why it's not showing there the range, but it is just appeared as any right there. So we have here you can see the land cover is 0, and then we have the random value, which is 0.5. So that differs for every point right here, as you can see. And properties right here 0.27, and Yeah, so we have 60% of our points here for training, and validation is 40% of our points. So you can also print these training GCP so that you can see for yourself what data they contain. Okay, so the next step is to create a training set. So we are going to use the training GCPs and basically drill down on all of the band values, okay, that intersect our geometry point. So this will be made clear once we print this training data set. So let's run this function, run the print function. So as you can see here, the collection that we're going to use are the training GCPs, the properties is the land cover, and the scale is 10 for the Sentinel-2 dataset. So feature collection, so if you go here to the features, and let's say we have for 0, for this point 0, we have properties here. As you can see, we have the property of land cover here at the last, and then we have all of the band values, okay? So this is from band 1 to QA60. Okay, so we have that right there. And then the next step, so let's remove this print training. And then the next step is to create a classifier. So the classifier that we're going to use here is the random forest. You can search how random forest works, or you can review your notes from your remote sensing classes. So the syntax is basically you use the Earth Engine object classifier, and then you use the random forest algorithm, and then you use the function train. And then the arguments are the features, which is the training data set that we've created here, this one. And then the class property is land cover, and then the input properties is the filtered clip dot band name. So for the band names, so these basically are the band names right here from B1 to QA60. Okay, so those are the band names. Okay, now that we have a training set and also now that we have our classifier, we will apply it to our image. So this is the filtered clip, and then we use the classify function, and then we input our classifier here. So this is, again, this filtered clip is an image object, and then we use the classify function, and then we input our classifier that we just created here. So once we've created that, we can then add our classified image into our map. Okay, so as you can see right here, there are parameters here. Um, this one, the green, blue, and yellow. So this is a color palette that you can use. Because for the vegetation we are assigning green, and the blue is for the build up, and the yellow is for the bare land. Okay, so the minimum is 0 because the land cover that we used, we attributed values there, right, from 0 to 2, so 0, 1, and 2. And then the name of the layer here will be sample. Okay, let's just lengthen it a bit, sample classification, for it to be a lot clearer. Okay, so let's try running it. Okay, so we can see here our classification slowly appearing on our map. Sorry for the very slow internet connection. So let's just wait for a bit. So that right there, ladies and gentlemen, is our classified image, and it's actually really cool, right? So we can classify a satellite image from our browser, which is really nice. So the next step is to create a confusion matrix. Okay, so we will discuss that in the next video. So thank you for watching this video. I hope you learned something new, and I will see you in the next video.